Wouldn't it be more beneficial to have like lines on these or numbers on them, like Legos with measurements, or so that they could see the actual divisions? No.
You can buy them with them. I prefer them without, actually, because kids don't get bogged down when they're playing with them about what their value is, right? Because if I wanted to, I could say this little cube represents 3. If this is equal to 3, what's this equal to now? 6, right? You can buy cuisenaire rods that have the lines on them. I don't prefer them because it limits what they can be. Because I could say this is 100, this is 200, 300, right? So there are some people who have them that, and you'll find them, and they stick together and stuff too. They have nice plastic ones with little check marks in them, but I actually prefer them to not have that, but that's just me. So, but what I sometimes will do with them is I'll give kids centimeter grid paper. And when you have centimeter grid paper, these are exactly 1 centimeter wide and whatever number of centimeters long. So they fit perfectly on the centimeter grid paper, and they can color them right in on the centimeter grid paper. And so by just tracing them onto centimeter grid paper and coloring them, they start to figure out the names of them because they know that this is 5 centimeters long, and this is 9 centimeters long, and that's, or 10, 9, 8, and so on. Okay? So it is, it's useful for them to learn the number names, but when they're really little and we're just playing with them, I don't really want them to know what they're worth. I want them to know that if I put a blue and a red together, it's the same as if I put a red and a blue together. Or if I put a blue and a red and a yellow, I could put yellow and then blue and then red, and you know what? It still works. Okay? So, and a lot of what we do in primary is just let kids play with these things and then ask them good questions and see if they're noticing anything or discovering anything. Or can you make yellow in a different way? Can you put things together that are the same length as red? You know, stuff like that. Okay. The last task you had was, this one, and this is where you're putting trains of the same color together. Okay? So Jackie wanted to make trains using 3 purple rods because she likes purple. Can you make other trains the same length as Jackie's train using just 1 color?
4 light green.
4 light green? Does that work? Yay! It's another way to do it.
6 red.
6 red. Okay, so 6 red works the same length train. Is there any other way you can do it?
2 dark greens.
2 dark greens. That works.
12 white.
12 little whites. Cheating. Oops. Okay, so 12 little white, 2 dark greens, 6 red, 4 light greens, or 3 purples are all the same length. What does that tell us? What concept is this building? Multiples. It is. It's multiplication, right? What is the length of this train? 12 units. What fact do I see right here? Yep.
So, like, at what grade should they be figuring out that, you know, 2 gray ones? There's 2 gray ones and 1 red one.
They can play with this. They should know that 2 little white ones makes a red one in grade primary. Like if I put 2 of these together, it's the same as that. But they don't need to have that language of multiplication. They just need to play with it and say, notice the equivalence, right? So anytime they see a red, they know they could replace it with 2 whites, right? Or anytime they see a light green, they know they could replace it with 3 whites, and so on, right? So eventually they just know kind of these relationships informally. They don't really articulate them or need, like, they just kind of know, like, oh, I can always make, you know, purple with 4 little white ones or 2 red ones, right? And they start to notice those things because later on, then we'll give them language and we can root it back to things that they already have played with, okay? So we'll give them language around this, and in grade 2 or 3, when we're first beginning to teach multiplication, I can take and say, this is 3 sets of 4, right? My smartboard's not working, or this would be way prettier. So this is 3 sets of 4, but I notice that it's also the same as 4 sets of 3, also makes 12. Or 6 lengths of 2 makes 12. Or 2 lengths of 6 makes 12, right? Or 12 lengths of 1. I could also do this with 1 length of 12, but I don't have a 12. I only go to 10 in my cuisenaire rods, right? Okay. So what we're doing now is we're talking about language. Like if I have 2 6s, that's 12 units long. But if I have 6 2s, that's 12 units long. And guess what? Now I'm talking about commutativity of multiplication, right? So we can have grade 3s playing with these and doing multiplication. You can also do some really cool things with division with these that I didn't ask you to do. But for example, if I told you, suppose I asked you what 21 divided by 7, or 22, sorry, I'm on a remainder. If I said, what's 22 divided by 7, right? Well, I can take 7 and lie it next to it. And then I can take another 7. And I can take another 7. And I realize, well, I can put 3 7s alongside of there, and that's almost 22. But I actually have a remainder of 1. So 22 divided by 7 is 3, remainder 1. Right? And so you can do some division in grade 4 using these cuisenaire rods as well. And it's a nice way to kind of play around with, you know, can I divide this number by 7 evenly or not? And if it fits evenly, then I've divided it into that many partitions. And if I have stuff left over, then I know I have a remainder. Right? So cuisenaire rods can be used right from grade primary, really all the way up to junior high, because we use them for fractions in junior high. Because I can model like 1/2 is the same as 2 over 4 and 3 over 6 and all that kind of stuff. It's a proportional model for fractions. Okay, does that make sense?
Yeah.
Cool. Did you like those cuisenaire rods? Do you like playing with them? Okay, good. You can take 5 minutes to play with them while I go print out the thing that I forgot to print out 5 minutes ago.